Hello and welcome to this another important topic, and that's plasmolysis. So let's discuss plasmolysis. Plasmolysis or plasmolysis. This is our today's topic. Now welcome again to this plant physiology. In fact, what plasmolysis is. But before this important concept, you have to learn the osmosis, because that's where the concept starts and what's the basis of this plasmolysis. Now what plasmolysis is that, for example, if we talk in case of animal cells first, if this is animal cell, this is having nucleus, there are less number of vacuoles, this is put in a solution which is having the same concentration of solute. The solution or solute, where we can see sap inside cell and outside, this solution is having the same tonicity as per that of cell. This is called isotonic solution. Then this is isotonic solution. So the tonicity of this solution is equal to that of cell. Nothing will happen. No movement of water takes place. Neither water will come outside and nor this water will go inside. Even if there is a movement of single molecule of water from this towards this one, that will be counterbalanced or cancelled by another movement, and that's what's equilibrium stage. Even if you have the movement, that is cancelled by reverse movement, and that's what we can call that the net movement is zero. The solution in which cell, in which there is no movement, of anything from this cell towards outside, or no movement of water or whatever solution from this towards cell, this solution will be called the isotonic solution. And this is osmotic membrane, as this is permeable, semi-permeable membrane. We put another solution, again animal cell, little smaller size, and solution. Now if the contents are solute or solution or sap goes from cell, it comes outside because of exosmosis, and this solution will be called hypertonic solution. So this is hypertonic solution because moment of osmosis is from lower hypertonic to higher hypertonic. So we can say this is exosmosis. Exosmosis. Here nothing will happen, but in this case exosmosis will happen and solution will come outside from the cell. So this is hypertonic solution, this one, and we make another diagram, another cell put in solution. Here the solution will enter inside cell. That means solution is hypotonic as compared to cell. So solution is hypotonic and cell contents are hypertonic, and because of that water enters inside cell. Okay, so these are three important concepts: isotonic solution, hypertonic solution, and hypotonic solution. Here nothing will happen. Here the water will come outside through exosmosis because it's hypertonic solution. Cell is having hypotonic, and this contents or this solution will come out, water will come out because of we can say water will come out, in fact, because it's a permeable membrane. This is exosmosis, and here end osmosis will happen, and osmosis, that means the water will go inside cell because cell is having hypertonic solution and outside solution is hypotonic. So this is what actually osmosis is. The concept has been taken from osmosis, this exosmosis and osmosis. This is fine. Now things are more complicated now. Leave the isotonic solution. Suppose leaving this solution aside, we don't require it much more. Now in fact, so let us focus on the second and third solution. So this was actually, I was concerned with the animal cell. Because of hypertonic solution, if we increase the hypertonicity of solution, all contents will come out, or water will come out of cell. The cell will die in fact. Okay, and in this case, if we allow more and more movement of water, the cell will become bigger, and it will burst into pieces. Those are called cell ghosts. This happens with animals. But let's take plant cells. In plant cells we have cell wall. This does not happen there. The ghost formation, the death of cell does not happen because of presence of cell wall. So this was the related phenomena with animal cells. So let's take example. In fact, our concern, that is plant cell. Now you look in case of plants, there is wall, well defined wall, cell wall is there in fact, and that's what we make here. This is cell membrane. In this way, there are vacuoles also, and vacuoles have a membrane which is called the tonoplast, and that's also semi-permeable membrane. The cell membrane is semi-permeable, but the wall is permeable to everything. Now if we put this plant cell in a solution having more concentration, so solution is hypertonic. Now this is the important, because this is what we are discussing, plasmolysis, hypertonic. This is hypertonic solution. The cell will release water, the water will come outside this solution, water will come in this solution, and the cell will decrease in size. Cell membrane in fact will decrease in size. So the second stage of cell can be like this. Also the water or sap present inside vacuoles will also come out. The cell will be like this. So it will be like this. And if we reach to the ending stage, the cell will be finally having like this shape. This is shrunken cell state, and this process, this phenomena of decreasing cell size, shrinking cell size because of presence of hypertonic solution outside is called plasmolysis. Simple. So plasmolysis is simply shrinking of cell size, cell volume, and coming of this cell membrane away from walls and get it decreasing in size, shrinking in size. This is when putting in hypertonic solution, this is plasmolysis. Now there is one important concept related with this plasmolysis, and that is de-plasmolysis. That is de-plasmolysis. Now de-plasmolysis occurs after plasmolysis, but it occurs shortly after plasmolysis. If we put cell in a plasmolysis state for some time, this cell will again die. So this will definitely follow. The de-plasmolysis will follow immediately, not after a great interval of time, because then cell will die and it will not come back. Now de-plasmolysis is coming back of the cell towards these walls, having full turgid state. Now plasmolyzer cell is called flaccid state. When it is shrunken to its minimum size, it is called a flaccid state. When the cell has taken the water in again, when we are putting it hypotonic solution, the cell will take water inside, it will increase in size, and it will become full turgid. Now that is called a turgid state. So turgid state will be reaching in deplasmolysis. In plasmolysis, we'll be getting flaccid state. Now plasmolysis has got three important stages, in fact, and that's important. Plasmolysis has got three important stages, and one is limiting, then we have incipient, then we have evident. Through three stages of plasmolysis can be this cell wall. This cell is full in size with cell wall like this. This is first stage. When cells start having minimum size, suppose this cell is starting having a minimum size, but it has not withdrawn from walls. Remember, cells starting having a minimum size of cell is having minimum size but not withdrawal from walls. So cell membrane has not withdrawn from walls, but cell has minimum size, it starts decreasing. This stage is called first stage, that is limiting. Now these are actually stages of plasmolysis. In second stage, the cell will start withdrawing from some points, but it still has having kind of touch with cell wall. It start withdrawing from some points. This is called incipient plasmolysis, limiting plasma, incipient plasmolysis. Then third, when cell has completely withdrawn from all the points and reached to the minimum stage like this, shrunken stage, this is called evident. This is evident plasmolysis. These are three stages, in fact, of plasmolysis. Now, do you know that we are in practical? In fact, the limiting plasmolysis is used for studies, to study plasmolysis, or we can say the osmotic potential of a cell can be studied by using this limiting, but in practical it is incipient which is used. So we can say it is used to know the osmotic potential of a cell, and it is concerned in its contents, but in practicals it is incipient. So in practicals it is incipient which is used, but overall the limiting is used for this, for the study of osmotic potential. The common, we can say the common substrates used for this study of plasmolysis are, number first plant is, that is Tradescantia, and second is Spirogyra. So these are important substrates, practical substrates on which we can study this plasmolysis, is Tradescantia and Spirogyra. So here we are peeling off lower side, peeling off lower side. This is a practical substratum used for study of the plasmolysis, Tradescantia, and this Spirogyra. Now, this is what is plasmolysis, basic concept of plasmolysis. It's again related with osmosis. Then we studied the concept of de-plasmolysis and stages of plasmolysis. In fact, the first thing that hypertonic solution is important to study all these things, and plasmolysis, de-plasmolysis is used, for different things. Even in case of God cells, you will come to know that in case of transpiration, the gourds will become turgid and flaccid. That is a kind of regulation. And in many other ways, in case of plants having the movement, touch me not, and other plants taxes having different taxes, attractions, repulsions, so it is used in plant movements also. So the cell, because of it is shrinking and then becoming turgid, this is a kind of movement inside cell, and that's then related to the big movement in different plants. We'll be studying in plant movements, in fact. Now, one more important point is that in case of when we have used that the de-plasmolysis, the cell start when it increases in size, water enters, it exerts pressure on the cell wall. This is called turgor pressure. Because it is a turgid state, this is called turgor pressure. So everywhere you will find pressures. Just turgor pressure, but cell wall is not that type that it will have a kind of bearing this. It will exert opposite pressure, that's called wall pressure. So that cell will not go on to become a ghost or burst, as in case of animal cells. It will not burst. Ghosts are not found here because cell wall prevents that phenomena. With this, I complete this important and a basic topic. That's what's called plasmolysis and related phenomena. Hope we'll meet again. Till that time, take care. Goodbye.